Hi guys, welcome. Why have we gathered today? Well, first of all, I hope that you are in the best of your health and energies because today we have gathered to solve a sample paper which covers all the questions from where? From your entire mathematics syllabus. You will be finding questions coming from each and every chapter in this paper. And this is what is going to be your practice. And why do you need to practice a paper, a question paper, which is covering questions from the entire mathematics syllabus? Well, let me cite a small situation before you. Suppose I give you a question from one specific chapter of your mathematics syllabus, okay? In order to attempt a question from one specific chapter, you need to recall all the concepts from that one single chapter and then apply the concepts to attempt that question. Now, recalling all the concepts of one single chapter is a pretty easy task, correct? That is why solving questions of one specific chapter is again a very easy task. But in your exam question papers, these kind of things do not happen. The question paper poses in front of you questions from all the chapters of your entire syllabus. And that means the question paper demands from you to be able to recall concepts of every chapter. The first question will be demanding of you to be able to recall a certain concept. Then the second question in the paper is going to come from a different chapter and thereby it will be demanding from you to be able to recall a different concept altogether. And similarly, question number 3 is going to come up from yet another chapter, thereby demanding from you to be able to recall a certain yet another concept. That means in those limited 2 to 3 hours, you will be demanded to be able to recall all the different types of wide variety of concepts which are covered in your entire math syllabus. Isn't this sounding to be a tedious task? Well, where there's a will, there's a way. There is a very nice way in which you can combat this panicky situation and keep yourself in a very comfortable one. And the thing which comes to the rescue to basically safeguard us from being trapped in a situation like this, wherein we are sitting to attempt a paper and we have to basically stress our brain to be able to recall every concept in those 2 to 3 hours. The thing which comes to the rescue is solving of question papers. Yes, that is it. That is why today we will be solving a question paper which is going to give a practice to you. In fact, it is going to train your brain to not become panicky while attempting the actual question paper. Okay? So let's get started in order to see how to work out with the questions asked in the question paper which cover the entire conceptual knowledge of your entire math syllabus. Now this question paper is divided into 4 sections. Section A, B, C and D, you know the pattern. We will be starting with section A, the very short answer type questions, and the questions in this particular section will be ranging from number 1 to number 8. So 8 questions are there which are very short answer type questions. Let's get started with the very first one. Okay, let's see what the first question is demanding. A rope that attaches a swing to a tree is 2.6 meters long. So there is a rope which is attaching a swing to a tree. So just suppose, just for example, in a very rough way, I'm drawing a tree. Suppose there's a tree and there is this rope which is doing what? Now suppose this is some kind of a swing, a rough diagram. Now this is a rope which is attaching this swing to the tree. So this is your swing and this is obviously your tree. This rope which is attaching the swing to the tree is 2.6 meters long. That means the length of this rope is 2.6 meters. Isn't it easy till here? So we are just trying to interpret the question in our imagination. Next it says, and the maximum difference between trajectories is an angle of 150 degrees. Now what does this mean? It is saying the maximum angle between trajectories is 150 degrees. Now what do I do in order to make you understand that part of the question? This imaginary situation in an actual form, let's convert it into a mathematical diagram. Now what happens if suppose this is your tree, okay, and then there is this rope to which there is this swing which is attached. Fine. Now what happens? This is the swing, this is the tree, right? Now this swing starts swinging in a to and fro motion. This swing, what is the swing's task? The task is to swing. So the swing is swinging. Now just imagine this swing is going to swing here sometime and then it's going to cover some distance here as well, right? It's going to go like this, then it is going to go like this. Now what is going to happen? This is going to lead to trajectories. What are they? These. And when the swing swings, it gives rise to trajectories which basically subtend some angle theta at point T. That means whenever here is a swing, it is swinging, it is covering some distance on the left and some distance on the right. So this is the point to which the swing goes on the left and this is the point to which the swing goes on the right. And these 2 points are basically interpreted as 2 trajectories, 2 paths which are falling from point T to this point and point T to this point, and the angle between these 2 trajectories is the angle subtended by this particular distance that you can see which the swing is covering. So whenever the swing covers a certain distance, see, this is the distance which the swing is covering when it is swinging. Whenever the swing is going to cover some distance, that distance is going to be corresponding to the angle theta, which is going to be subtended at the point T by the trajectories brought into picture by the movement of the swing. Okay? What did I say? I said whenever the swing is going to swing, it is going to cover some distance on the left and on the right. So overall, it is going to cover some distance. Whenever the swing is going to cover some distance, it will be bringing in picture a certain angle theta, always. So, the distance, whenever the swing is covering some distance, there is some theta coming into picture. Now, mind it, how did this theta come into picture? Depending upon how much the swing is moving to the left and how much the swing is moving to the right, we had obtained these 2 points. And these 2 points were joined by the point T, thereby giving us these 2 trajectories, and therefore we brought into picture the angle theta. Now suppose from this point I move to this kind of a situation where this is, say, my point T, this is the rope and this is my, say, the swing. Now what happens? Now the swing moves to the left like this and it moves to the right like this. That means the distance covered by the swing in this particular situation is more than the distance covered by the swing in this situation number 1. Suppose this is situation number 2. Now again, because these are the 2 points to which the swing is swinging to the left and to the right, these are going to give rise to trajectories, isn't it? And therefore, an angle theta is going to be brought into picture. Now, carefully observe situation 1 and situation 2. if this swing is swinging more distance, if it is covering more distance, the angle subtended by this particular portion between these two trajectories increases. And when it is swinging less amount of distance, when it is covering less amount of distance when it is swinging, the angle which is made by the two trajectories is lesser. So more the swing is going to swing, more is the distance which is subtended at the point T. Lesser the swing is swinging, lesser is the angle between the trajectories. That means, when will be this angle maximum? This angle will be maximum when the distance covered by the swing is maximum. Right? Suppose there is this swing, it can swing like this, then it can swing more, then it can swing more, but obviously in every swing in which you must have sat, there is a maximum point to which that swing goes to the left and the maximum point to which that swing goes to the right. Suppose that swing is swinging to the maximum. That means it's going to the maximum point on the left and on the maximum point on the right. That means that swing is covering the maximum distance when it is swinging in that pattern. That means the swing is covering the maximum distance, and that is why by those two end points on the left and right, when you are going to bring into picture the two trajectories, the angle formed here will be the maximum. Okay? So when the distance is maximum, the angle is maximum. When the angle is maximum, suppose we reverse our argument, when your angle is maximum, in that particular case, the distance will be maximum, isn't it? Suppose I say this is my maximum angle. This is the maximum angle which can be made by the trajectories coming as a result of these two endpoints. If this is the maximum angle coming as a result of these two endpoints, because the trajectories are made from these two endpoints, that means the swing can at the maximum swing this much distance. Because if the swing covers more distance, the angle is going to increase, isn't it? But this angle I am saying is the maximum angle. That means this distance in that case covered by the swing is the maximum. Okay? So the maximum distance is going to give rise to the maximum angle, and the maximum angle is going to give rise to the maximum distance. Okay? So when your angle is maximum, the distance covered by the swing when it is swinging is maximum. And when the distance covered by the swing when it is swinging is maximum, the angle subtended by the trajectories is maximum. Okay? Now let's see what the question says in the next part. It said that the maximum difference between the trajectories is an angle of 150 degrees. So here the question is giving you the maximum angle. What is it saying? What is it saying here is that when this was your tree and this was the point which is your swing, it is saying that the maximum angle which can be made by the trajectories when the swing is basically swinging is 150 degrees. That means this is the maximum point to which the swing can move to the left, and this is the maximum point to which the swing can move to the right. Because when it is covering this much distance, the angle made by these two trajectories is maximum. That means the swing cannot move beyond this. Because if it would have moved beyond this, the angle covered in that case by the trajectories would have been more than 150. But the question says that 150 is the maximum angle. That means if 150 is the maximum angle, this distance is the maximum distance, this much, which can be covered by this swing. Okay? And after we have observed this, we have observed that if 150 is the maximum angle, then this distance from this point to this point, say this is point A and this is point B, then this distance from point A to point B is the maximum distance which is covered by the swing. The question is, find for me this maximum distance. Will it be 4.2 meters? The distance which is covered by the swing when it is swinging, which is the maximum, is it 4.2 meters? Is it 6.8 meters? Is it 13.2 meters? Or is it 8.6 meters? That is the question. So I know that from point A to point B the distance covered by the swing is maximum. But what is its value? I have to find the value of this maximum distance which is coming as a result of this maximum angle subtended at point T by the trajectories made. Okay? So I have the aim is to find what? Length of AB. This AB has a certain length. I have to find that length. Now, how to find the length of AB? How? Basically, what is this figure resembling? Now, over here you have to whack your brain a little bit and recall the figure of a sector. Can I say that this entire region is nothing but it is resembling a sector? Sector of what? So, I am trying to say that this portion, basically, if I try to make a circle. Now, don't forget there is one more thing given in the question. The distance, basically the length of the rope from the tree to the swing was 2.6 meters. So, over here from the tree to the swing, this distance is still 2.6 meters. Okay? In fact, this itself is also 2.6 meters and this is also 2.6 meters. Right? That is what is the case. Now, this swing is swinging. So, the rope length will not decrease, right? This is the swing's rope. It is swinging. The rope's length is not decreasing. It is going to be 2.6 always. Whether it swings to here or it swings here. In middle, if the distance or the length of the rope is 2.6, here also it will be 2.6. Here also it will be 2.6. So, when the swing is swinging, the length of the rope is not altering, it is not changing. So, over here also when the swing comes over here, now the point of the swing changes from here to here. When the swing moves, it comes here. So, the rope still is 2.6 meters, then it comes back, then it goes here when it is swinging. Again the length of the rope is 2.6, right? So, that means this is also 2.6, this is also 2.6. In fact, at every point, the distance from point T to this particular point anywhere over here on AB, the distance of point T to any point on AB is 2.6 meters. Because the length of the rope is not changing. So, the distance from any point on AB to point T is 2.6 meters. Okay? That is what is giving me the idea to consider this particular region as a sector of a circle. Now, suppose I draw a circle and I say that the center of the circle is point T and that circle has radius equal to 2.6 meters. So, I draw a circle of radius 2.6 meters and I am taking this point T as the center, radius as 2.6 meters. So, this point will be my S point. And suppose over here I subtend this angle of 150 degrees. In that case, if you consider this region, if you consider, isn't this the exact same region like this? Isn't it? This is the exact same region like this. I am marking this point as A and this point as B. Because T is the center, that is why from any point on AB or any point on the circle, the distance of any point on the circle to point T is equal to the radius, which is 2.6. Right? And so these two pictures exactly are copies of each other. That means right now individually the situation which I interpreted from the question, I just pushed it inside the concept of sector of a circle. this concept, from this imaginary situation, we have landed ourselves to the sector of a circle concept. And if I wish to find the distance travelled by the swing, which is from A to B, when the angle subtended at point T is 150 degrees, when I look at the same situation in the form of sector of a circle, what I wish to find is, my aim becomes what? So now my aim becomes to find, now still I have to find the same thing. I have to find this only. This is what I have to find. I have to find the length from A to B. That's the distance covered by the swing when the angle subtended is maximum 150 degrees. But this time the language will be different. I have to find the length of arc AB. Now it's an arc. It is one portion of the entire boundary of the circle. This is one particular portion of the entire boundary of the circle. So now AB has become an arc. In fact, this is the arc which is bringing the sector ATB in existence. So I have to find the length of arc AB of the sector ATB. So this sector ATB has arc AB and it has the angle ATB. So to find length of an arc AB of sector ATB when angle subtended by the arc AB of the sector ATB at the center of the circle. So this arc subtends an angle of 150 degrees at the center of the circle T. So at the center of the circle of radius 2.6 meters is 150 degrees. Let's read again. The aim now from just to find the length of AB in this diagram has converted to what? I have to now find the length of the arc AB. So we are converting our entire situation into mathematical terms, okay? Because we have to recall concepts of mathematics, right? To find length of the arc AB of sector ATB when the angle subtended by the arc AB at the center of the circle of radius 2.6 meters is 150 degrees. Now this entire paragraph is going to make you recall. This is enough to give you the hint as to what is the formula we are trying to bring into picture. When you have a sector, that sector comes into existence by two things. The first thing which makes that sector come into existence is the arc, and the second thing which makes that sector come into existence is the angle. When you know the angle of the sector, can you find out the length of the arc of that sector? Yes, of course, we have done that formula. What is that formula which basically makes us give the value of the length of the arc of that sector with the help of the angle of that sector? Why don't you recall for a moment what that formula is, because that is the only thing required to combat and deal and tackle with this question, and then I am going to come and complete it with you. So because we have to do something that we already know, so were you able to recall the concept which I asked you to recall? Well, over here, what is required is the formula of finding the length of the arc of a sector when the angle of that sector is something that is known to us. And so, the formula which comes into picture is the length L. The length L of a sector of angle theta. So suppose I know my thetas, L is something that I don't know. So the length L of a sector of angle theta in a circle. So this sector is a sector of the circle of radius r is given by. Students who must have been able to recall this formula, this question would have been cakewalk for you, because this is the only formula which is being tested in this question. What is the formula of finding the length of the sector of angle theta in a circle of radius r? It is pi into r divided by 180 degrees into theta. And therefore, here we are going to put pi as 22 by 7. R is what? R is the radius of the circle. Radius of this circle is 2.6 meters given in the question. 180 already we know. We are going to plug in 180. And what is the theta? Theta is the angle of the sector. So the angle is 150 degrees. And thus, length of the arc of this sector, which is the length of the arc AB, which is nothing but the distance, the maximum distance travelled by the swing. Thus, the maximum distance travelled by the swing is equal to the length of arc AB, and the length of arc AB we know, we find like this. So pi, plug in the value of pi, plug in the value of r, plug in the value of theta, divided by 180 degrees. That's it. This is the only expression which you need to solve, and you are going to come up with something meters, some measurement of meters, and that is going to give you the length of the arc AB, or the maximum distance travelled by the swing. I am saying that distance travelled by the swing from A to B will be maximum, because the angle which can be made by the trajectories is maximum. And if angle is maximum, we know that the distance travelled by the swing is maximum. It cannot travel any more distance, because if it travels any more distance, the angle will increase, and there is no argument of getting this angle increased, because it is already at its maximum. And so the distance will be maximum, which is this, and when you sort this out, this value comes out to be 6.8 meters, which gives you option B as your correct option. This is the only concept, the concept of, first of all, interpreting the situation in the form of sector of a circle was one task, and the second task was to be able to recall this formula, because once you are able to recall this formula, everything is known to you which is unknown in this formula. You just need to plug in the values of all the unknowns and get the answer. So these two things, if you were able to do in this question would have been very, very easy for you. Understand the ideas which we have used to deal with this question, because it's the ideas which help you tackle with a question. Let's now see what comes up as a task in the next question. Okay. So here I am given 3 points, k plus 1, 1, 2k plus 1, 3, 2k plus 2, 2k. The question is, these 3 points, suppose I say this is my point A, this is my point B, and this is my point C. The question is saying, suppose these 3 points are collinear. Now in these 3 points you can see there is one unknown kept. Right? I want such a value of k such that when I plug in that value of k in the coordinates of these 3 points, I get 3 points which lie on one single line. Right now, I want these 3 points to be collinear. I want these 3 points to be lying on one single line. But the question is, I don't have that real number, that number k, which on getting plugged in these 3 points can give me the actual coordinates of the 3 points which are lying on one single line. That means right now I know these 3 points are collinear. I have to find the value of k, right? Now, in order to understand collinearity, there are 2 things which we need to know. The first thing is, suppose you have 3 points. Over here also you have 3 points. Suppose you have 3 points with you, say A, say B and say C. Among these 3 points, you can have 2 cases. Case 1 is that 2 points out of 3 lie on one line. That means you have 3 points. Out of them, if 2 points, so this is your point A and this is your point B. Suppose out of 3 points, 2 points are lying on one straight line. But the third point is not lying, it's lying anywhere else. You know, anywhere else, but not on that same line. In this particular case, when out of the 3 points, 2 points, any 2 points are lying on one single line, but the third point is not lying on that line. In this case, when you join the 3 points, what happens? You get a triangle, isn't it? What did I say? You have 3 points. The first case says, out of 3 points, if any 2 points lie on one single straight line, that means any 2 points are collinear, but the third one does not lie on that line, it lies anywhere else. In that case, when you join these 3 points, you are going to get a full-fledged, good, neat, very nice looking triangle which is going to swipe some area. It is going to cover some area. Now it is sitting like this. This is a good full-fledged triangle. In order to sit like this, it needs this much area. It needs this much area to be able to completely sit like this, right? That means whenever 2 points out of the 3 points available to you are lying on one single line and the third point is not lying on that line, in that case when you join the 3 points, you get a full-fledged, some area covering triangle. You get a triangle which in order to sit needs a certain amount of area. It swipes a certain amount of area to be able to sit where it is sitting. But the case 2 happens to say something else. Case 2 says that suppose all 3 points lie on one single line. Then what happens? So suppose there is this straight line. And suppose all the 3 points A, B, C, all the 3 points lie on a straight line. In this particular case, when you join the 3 points, what do you get? Do you get a good looking full-fledged triangle which is covering some area? No. The joining of these 3 points is giving me a line segment which is a part of this entire line. It is not giving me a full-fledged area covering good looking triangle. No. Or I can say that the area covered by the triangle which is formed by joining these 3 points is 0. If I say that the area covered by the triangle which is formed by these 3 points or joining of these 3 points is 0, that means there is no triangle, right? If there would have been a good looking full-fledged triangle, it would have covered some area. But here, because the triangle's area is 0, it is another way of saying that there is no full-fledged triangle formed which has ABC as its vertices. And that is what we have to use over here. Because if 3 points are lying on the same line, the area covered by the triangle formed by joining these 3 points is 0. Correct? I just explained you. And that is why if these are the 3 points which are collinear, when I join them, I am going to get a straight line. And therefore, I am not going to get a full-fledged good-looking area covering triangle. Or I can say that the area covered by the triangle formed by joining these 3 points is 0. And that is what we are going to use in our proof. Let A be the first point which is k plus 1 comma 1. Let the second point be denoted by B which is 2k plus 1 comma 3. And let the third point which is 2k plus 2 comma 2k be denoted by C. Let these be the 3 collinear points. Understood? Now, you can take k plus 1 as x1, 1 as y1, 2k plus 1 as x2, 3 as y2, 2k plus 2 as x3, this as y3. Why am I doing this? Well, let's just get started. If these are the 3 points which are collinear points, then area of the triangle which is made by joining these 3 points or which has vertices as A, B and C, therefore triangle ABC, area of the triangle ABC in this case will be 0. But if you have 3 points with coordinates as x1, y1, x2, y2, x3, y3, suppose you have, what I'm trying to say is, suppose you have a triangle with points A, x1, y1, B, x2, y2 and C, x3, y3. In this case, what is the area of this triangle? The question is only demanding from you to be able to recall the formula of area of a triangle ABC when you know the coordinates of the vertices of the triangle. So when the coordinates of the vertices of the triangle, the 3 points which are the vertices of the triangle are known, with the help of the coordinates of the vertices of a triangle, can you find out the area of the triangle? The answer is yes. What is the formula? You take half multiplied by mod of what? Well, you do something. You write x, then you write a y, then you write another y, plus. Then you write x, then you write a y, and then another y, with a minus sign in between, plus, then you write x, then you write a y minus another y. Now this you do 3 times and then you close the mod. And one rule which you adopt is that from 1 we will be going to 2, from 2 we will be going to 3, from 3 we will be going to 1 and so on. Okay? So over here what I will do is I'll start from 1 I'll go to 2, from 2 I'll go to 3. Then I'll start from 2 this time. After 1 I'll start from 2 I'll go to 3, from 3 I'll go to 1. After that I'll start from 3 I'll go to 1, from 1 I'll go to 2. And this is the formula of area of a triangle ABC when you know the coordinates of the 3 vertices of a triangle. It is half mod of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. And so, once this concept of area of a triangle is clear to you, we just have to plug in that formula over here and equate it to 0 with the coordinates of the 3 points A, B, C being this, this and this. So let's do that. What is it that we will be doing now? Just plugging in the values of x1, y1, x2, y2 and x3, y3 in the formula of triangle ABC and equating it with 0, because the area of this triangle ABC, which is given in the context, is 0. So we have half of mod of x1. What is x1? K plus 1. y2 minus y3. y2 is 3, y3 is 2k, so you have 3 minus 2k plus x2. x2 is 2k plus 1. x2, then y3 minus y1. So 2k minus 1. Plus x3. x3 is 2k plus 2. So x3, y1 minus y2. 1 minus 3. Mod close equal to 0, because area of the triangle is 0 in this case. So that is what I have got. Now this half goes and gets cross multiplied to 0 over there, and therefore this vanishes. Now you should know that mod of a quantity is 0 if and only if the quantity inside the mod is 0, right? You know that mod of x is 0 only when x is 0. Mod of a quantity is 0 only when that quantity is 0. So if mod of this quantity is 0, this means that this quantity is 0. What is this quantity? K plus 1 into 3, which gives you 3k plus 3 minus 2k square minus 2k plus 4k square minus 2k plus 2k minus 1. Then you have, this becomes 1 minus 3, which is minus 2, right? So you get 2k into minus 2, which gives you minus 4k minus 4. So if mod of this quantity is 0, that means this quantity is 0, which in simplified format is this. Now is anything getting cancelled over here? Well, of course, plus 2k minus 2k gets cancelled. Anything else? No, nothing else. Let's just collect the terms now. Minus 2k square plus 4k square gives you plus 2k square. After that you have 3k minus 2k, which gives you 1k. 1k minus 4k gives you minus 3k. Then you have plus 3 minus 1, which gives you 2, and 2 minus 4 gives you minus 2. Once you have sorted this out, don't forget you have to find the value of k, okay? So here, if you recall, this is resembling something. If I replace k by x, what does this become? The unknown becomes 2x square minus 3x minus 2 is 0. Now, are you able to recall of something? Well, this particular expression resembles an expression of ax square plus bx plus c equals 0. Right? What is this? This is the quadratic equation. I can write this particular equation in this format. What? On how? So ax square, a is 2. So 2x square plus b into x. So b becomes minus 3 into x plus the constant term c. So plus c. So this is your small a, this is your small b, and this is your small c. And therefore this resembles the quadratic equation. And I know how to find out the roots of a quadratic equation. And therefore I am going to apply that knowledge to find out the roots of this quadratic equation. Okay? So let's do that. I have to just apply the formula of roots of a quadratic equation. Correct? That is what I have to do. So, if ax square plus bx plus c is your quadratic equation, how are the roots, which is the value of x, given to you? Well, x is equal to minus b plus minus under root b square minus 4ac upon 2 into a, where you know what is a, what is b, and what is c. So, when over here I know what are my ABCs, can I find out the roots of this quadratic equation? Yes. So, thus x comes out to be equal to minus b. So, your b is minus 3, minus of b will be minus of minus 3, which is 3, plus minus under root b square. So, what is your b square? B square is minus 3 square, which is 9, minus 4 into a into c. So, your a is 2, c is minus 2. So, ac will be minus 4 whole upon 2 into a, and your a is 2. Let's solve this. What does this become? 3 plus minus 9 plus 16. 9 plus 16 gives you 25 whole upon 4, which gives you what? Now this gives you 3 plus minus 5 upon 4. Root 25 is 5. So you get 3 plus 5 upon 4 and 3 minus 5 upon 4. 3 plus 5 upon 4 gives you 8 upon 4, which is 2. 3 minus 5 upon 4 gives you minus 2 upon 4, which is minus 1 by 2. That means those values of x which satisfy this quadratic equation are 2 and minus 2. But this quadratic equation was obtained when the variable x was replaced, or k was replaced by x. That means the original quadratic equation was this quadratic equation in the variable k, right? That means if the same quadratic equation in the variable x is giving you the value of x to be 2 and minus 1 by 2, the same quadratic equation in the variable k implies that your k is equal to 2 and minus 1 by 2, right? When x was written over here, I have got x to be equal to 2 and minus 1 by 2. When I replace this variable by k and I solve this for k, I get k is equal to 2 and minus 1 by 2. These are just variables. That means this question has used not just the concept of area of triangle, but has also used a concept from completely another chapter, which is quadratic equations. It has used the formula of solving a quadratic equation, which is the Sridharacharya or the quadratic formula. Okay? And these two concepts have made possible for us to be able to solve this question, and therefore the value of k, which on getting plugged in gives me the coordinates of 3 points which lie on one single line, is option number B, where k is equal to 2 and minus 1 by 2, right? That is how these questions are supposed to be dealt with. Okay? Not at all difficult. The only thing which is a task is the practice of questions like these. Because they basically give your brain a training as to how to recall concepts from different chapters in one single time. Now this question was one question, but it was taking into use concepts from two different chapters. That is what is the practice which you need, your brain needs. That is why it is important to do question papers like these. Let's look at the third question now. Okay, what is the question trying to say? Let's read. There is a rectangular block of dimensions 6 centimeters, 12 centimeters and 15 centimeters. These are the dimensions of a rectangular block. That means the length is given, breadth is given, height is given. Okay, that means this rectangular block is nothing but a cuboidal block with a certain length, certain breadth and certain height. The moment we have read till here, you know somehow the volume of cuboid, that chapter is going to come into picture, surface area and volumes, right? So just keep on recalling, because the moment you are able to interpret the question, you are going to move to that particular chapter. So first of all, you should be able to connect with the question, and then only you can connect it to the exact chapter which is used over here. So a rectangular block of these dimension is given to you. It is cut. It is cut into some number of equal cubes. What is happening? You have a cuboidal block. Okay, there is a certain cuboid that you have. Let's just make it. Now you have a cuboid with you. If this cuboid is cut into what? Now if this cuboid, certain kind of a cuboid is cut into cubes, equal number of cubes, suppose this cuboid is cut into, what are you going to get? Okay, so you can make a better cuboid than me. Okay, so suppose this is a cuboid which is cut into equal number of cubes, or basically not equal number of cubes but exact number of equal cubes. That means this cuboid will be cut into small cubes of equal dimension. Okay, so roughly if I make first cube, second cube, third cube, fourth cube and like so on, something like this is going to keep on happening, isn't it? The entire space will be filled when you are cutting cubes from a cuboid. Just imagine if you have a room full of balloons, okay? If you have a room full of balloons, the entire room is filled up with balloons. Now suppose I give you very small sized balloons, okay? If I give you very small sized balloons, you will be needing lots of balloons to cover the entire room. To cover the entire space of the room, you will be needing lots of balloons. But if I increase the size of the balloon, I give you big balloons, in that case, in order to cover the same room, in order to cover the space of the exact same room, you will be needing less number of balloons. Bigger the size of the balloons, you will be needing lesser number of balloons to cover the room. But smaller the size of the balloons, you will be needing lots of balloons to cover the room. Okay, this is one thing. The next thing which I want to make clear to you is that when the balloons are covering the room, each balloon is acquiring a certain amount of volume from the entire volume of the room, isn't it? There is a certain space in the room, there is a certain volume of the room. When the room is covered by the balloons completely, that means the volume acquired by all the balloons is equal to the volume of the room. Why is this happening? Because each balloon is acquiring a certain portion of the volume of the room. So when you add all the small volumes which are there being acquired by the balloons, you get, when the entire volume is added, you get the volume is same as the volume of the entire room. That means if this is a room which is covered completely by the balloons, like completely, the space which you are right now seeing to be, vacant in between, it's also not vacant. So I cannot draw that situation on the board, but somehow just to make you imagine, these spaces are also not left vacant. So what I'm trying to say is, when this room has a certain space, it has a certain volume. When all the balloons come and cover the entire room, each balloon is acquiring some portion of the volume of the entire room. That means when you add the volumes of all the balloons volume, when you add, what do you get? When you add the volume of each and every balloon, you get the volume of the entire room. That means volume of all the balloons taken together which cover the room is equal to the volume of the entire room. Correct? Because none of the spaces are being left. Nothing is being left. Everything is being covered by balloons in the room. Similarly, in this situation, what is happening is, you have a cuboid. That cuboid has a certain volume, isn't it? Right? Now that cuboid is cut into small cubes. That means if I do not say the language of getting cut into cubes, in fact I am saying if there are small cubes kept in the cuboid, for example. There is a cuboid in which small cubes are kept such that the entire cuboid is covered. So you are basically searching for a dimension, a particular length of the cube such that you collect many cubes of the exact same dimension, equal sized cubes, and you cover the entire cuboid with those equal sized cubes such that the entire cuboid is covered with those small equal sized cubes. Now obviously when that cuboid is covered by so many small equal sized cubes, each cube is going to contain some portion of the volume of the entire cuboid, right? Such a situation will only occur, right? And that means when you are going to add the volumes of all the small cubes which are covering the cuboid completely, you are going to get that the added volume which is covered by all the cubes taken together is equal to the volume of the cuboid, right? And that is why you have to recall over here two formulas. One is volume of the cuboid is what? Everybody knows volume of the cuboid is length into breadth into height cubic units. And on the other hand, the next formula which you need is volume of the cube. Volume of the cube is side cube, because inside a cube is nothing but a cuboid in which length is equal to the breadth is equal to the height. So you have just one dimension which is the side, then you get side into side which gives you side cube cubic units. And then because the cuboid is being covered up by small equal sized cubes, that means the volume of the cuboid is equal to what? Well, suppose let K be the number of equal sized cubes covering the entire cuboid. Suppose the entire cuboid is covered by k number of small equal sized cubes. K is the number of cubes which are covering the entire cuboid. Okay, all of them are of equal size. Do not forget this. So, if this is the case and let the size of each cube, which is, they are equal sized cubes. So, let the size of each cube, it will be same. Let the size of each cube be n, say n centimeters. Let the size of each cube be n centimeters. Okay? If size of each cube is n centimeters, the volume acquired by each cube is n cube, and there are k such cubes. So, n cube plus n cube plus n cube plus n cube k times. That's what we have to do. We have to add the volumes of all the cubes which are covering the entire cuboid. And when I add the volumes of all the small equal sized cubes which are covering the cuboid, that added up volume is going to come out to be equal to the volume of the cuboid, right? So what is the volume of, or the added volume of all the cubes? N cube plus 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 n cube. How many times? K times. So k times n cube is the volume of all the cubes which are covering the entire cuboid. And so, volume of the cuboid will be equal to n cube plus n cube plus n cube k times, which gives you k times n cube. And this added up volume will be equal to the volume of the cuboid, which is length into breadth into height, which is 6 into 12 into 15. This centimeter cube is equal to k into n cube centimeter cube. Okay? Now the question starts. What is 6 into 12 into 15? It is 1080. 1080 is equal to k into n cube. Don't forget, k is the number of cubes and n is the size of each cube, basically the dimension of each cube. Now, the question is, what is the least possible number of cubes? Now, there are cubes which are covering my cuboid. What is the least number of cubes which will be required to cover the cuboid? Again, recall the balloon concept. If you take small sized balloons, you will require so many of them to cover the room. But if you increase the size of the balloon, the lesser number of balloons will be needed to cover the same room. That means if you want the least possible number of cubes to cover the cuboid, or that is what you need if you want the least number of cubes, if you want this k to be the least number which is required to cover the cuboid, that means you want the size of the cubes to be more, right? The maximum size of the cube which is delivering you with an integer k, a positive integer k, is going to be the least number k, which is the number of cubes required to fill the cuboid. I want the least number of cubes which are required to fill the cuboid. So what is it that I want? I want k, where k is 1080 upon n cube. If I want, now this k is what? K is the number of cubes. The number of cubes will be 1 cube, 2 cube, 3 cube, 4 cubes, 5 cubes, 6 cubes. That means this k should come out to be a positive integer, right? So this k is this, such that k comes out to be a positive integer, right? This is how we write positive integers. So k is equal to 1080 upon n cube, such that k is a positive integer. That means k comes out to be, say, 17. That means I need 17 cubes to cover my cuboid. My question is that I want least number of cubes. When will this k be the least? K is equal to a fraction. A fraction is least when the denominator is maximum. Greater the denominator, lesser is the value of the fraction. So if I want the least value for k, that means I want the least value of this fraction. That means I want the maximum value of the denominator. What is that n for which n cube is the maximum? Because that n for which n cube is the maximum is going to give me the value of k, which will be the least value of k. See the connection. N is standing for the size of the cube. I am interested in the maximum sized cubes. I am interested in the maximum size n, because if you take the maximum sized cubes, you are going to get the maximum denominator, and that is going to give you the least value of this fraction, and therefore least number of cubes which are required to cover the cuboid. Greater the size, lesser is the number of objects required to cover a certain space. And so let's get started with plugging in the values of n. Now n is standing for the size of cube. The one side of the cube is n centimeters. Now this can be either 1 centimeter, 2 centimeter, 3 centimeter. It cannot be minus 4 centimeters, minus 3 centimeters. And so I am going to start with 1. Let the size of the cube be 1 centimeter. The side of the cube be 1 centimeter. In this case, k will be 1080 upon 1 cube, which is 1, which is 1080. That means when you take cubes of size 1, side length 1, in that case you need 1080 cubes to cover the entire cuboid. Now obviously the volume of the cuboid is 1080, and if you have cubes, such small cubes of 1 length each, that means each cube is going to cover 1 cubic unit volume. So 1 plus 1 plus 1 plus 1, 1080 times I need to cover the volume of the entire cuboid. And that is why in this case I need 1080 cubes to cover my entire cuboid. Let n be equal to 2. If you take sides to be of 2 centimeters each of the cube, how many cubes do you need? 1080 divided by 2 cube, and 2 cube is 8. But when you divide this by this, you get that the k which is coming out is in points, it is in decimals, something point something. It doesn't come out to be a positive integer, a 1, a 2, a 3, a 4, a 5, a 6. No, it doesn't come out to be a number like that. That means I cannot take the side of the cube be of length 2 centimeters, because if I do that, I am not getting a certain number of cubes which can be used to cover the cuboid. So I cannot take sides to be of length 2. If I take sides to be of length 3 each, in this case my k comes out to be 1080 divided by 3 cube, which is 27, and this delivers you with 40. Okay? So if you take sides of the cube of 3 centimeters each, you need 40 cubes to cover the entire room, to cover the entire cuboid. Here, if you take cubes of sides of length 1 centimeters, you need 1080 cubes to cover the cuboid. If you increase the side length to 3, you need 40 cubes to cover the cuboid. Let's see if the number of cubes can decrease even more. If you take n to be 4, you get k to be equal to 1080 divided by 4 cube, which is 64. But on dividing 1080 by 64, you will get again that k is not coming out to be an integral value. It won't come out to be something like 40, something like a whole number. No, it won't come out like that. It is going to come out to be in points, and that is something I don't need. How can I pick up number of cubes in points to be able to cover my entire cuboid? I need whole numbers, I need integral answers, right? And so I cannot take n equals 4, I cannot take n equals 2. In fact, when you take n equals 5, 6, 7, 8, 9, when you take all of them, you get that k does not come out to be an integral value. So that means you cannot take the sides of the cube of length 5 centimeters, 6 centimeters, 7 centimeters, 8 centimeters and 9 centimeters. You cannot take these sizes, because if you take the sides of these lengths, you are not getting some number of cubes, some integral number of cubes, positive integral number of cubes which are required to cover the cuboid. And so you cannot take all of them. So let's go further. Let n be 10. Suppose you take cubes of 10 as the side length. In that case, k will be 1080 upon 10 cube. 10 cube is 10,000. Now 1080 upon 10,000, this 10,000 is so much bigger than 1080. So when you are going to divide this by this, you are going to get a number which is less than 1. That means you are going to get 0 point something something, right? And if I am getting 0 point something something, that means this point is saying that if you take cubes of length 10 centimeters, side length of 10 centimeters, you need 0 point something something number of cubes to arrange the entire or to cover the entire cuboid. Now, what is the meaning of take 0 point something something cubes? That means the moment I take 10 to be the side length of the cube, I am not getting an integral answer. No, I am not getting take 1 cube to cover the entire cuboid, or 2 cubes or 3 cubes or 80 cubes or 99 cubes. No, I am getting 0 point something number of cubes. What absurdness is that? And that means I cannot take 10 also. In fact, the moment you start moving beyond 10, 11, 12, 13, 14 and so on to be the sizes of the side length, you are going to get the denominator is getting bigger and bigger and bigger from 1080. And that is why this quantity is going to turn out to be smaller and smaller and smaller. 0 point something, then again 0 point something, again 0 point something. That means further from 10, we are going to get unacceptable values of k. That means from 1 to any number, the only two acceptable values which I am getting are corresponding to n equal 1 and n equal 3. When you take the side length of the cube of 1 centimeters, you get 1080 number of cubes to cover the entire cuboid. And when you increase the size to 3 centimeters, you get 40 cubes to cover the entire cuboid. That's it. You can either keep the size to be 1 or you can keep the size to be 3. The question is, give me the least number of cubes. So the least number of cubes will be coming into existence when you take the size of the cube to be, or the size of the side of the cube to be 3, and that is 40. So the answer is least number of cubes which are required to cover the cuboid, or least number of cubes in which this cuboid can be cut, equal sized cubes, is 40 cubes when you take the size of the side of the cube to be 3 centimeters. So your answer is 40 cubes. The maximum number of, if the question would have been giving the maximum number of cubes which are required to cover the cuboid, you would have said 1080 is the maximum number of cubes required to cover the cuboid, because the least length which I can give to the side is 1 centimeters. So in accordance with the least length of the cube, I am going to get many, or the maximum number of cubes to cover the cuboid. And with the maximum size of the cube, I am going to get least number of cubes to cover the cuboid. The minimum the size of the cube can be, or the size of the side length be, is 1 centimeters. So this corresponds to giving you the maximum number of cubes required to cover the cuboid. And because the maximum side length of the cube can be 3, that means this is going to give you the minimum number of cubes required to cover the cuboid. Bigger the object, lesser is the number of objects required to cover the space, and lesser the size of the object, larger is the number of objects required to cover a certain space. This is the only concept which was used to tackle this question. Otherwise, this question was very easy. Only two formulas from mathematics were demanded, and they were the volume of the cube and the volume of the cuboid. Okay? Let's move to the next question. This question says there is a 1.2 meters tall girl. Okay, so let's see. There is a girl. Okay, so this is the ground. She's standing on the ground. The height of the girl is 1.2 meters. Okay, next. The girl spots a balloon moving with the wind in a horizontal line. So, okay, so there is a balloon which is moving in a horizontal line with the wind. So, the same balloon is moving, okay? It's not like so many balloons are there. The same balloon is moving with the wind in a horizontal line. Okay? Once this scenario is there, this girl, now this girl has her eyes at this point, and this girl basically spots a balloon. She spots a balloon which is moving with the wind in a horizontal line, and this balloon is at a height from the ground. What is this height? The height of the balloon from the ground is 88.2 meters. Okay? So, the girl spots a balloon which is at a height of 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girl at that instant is 60 degrees. So, the angle of elevation, that means this is the observer, this balloon is the object, and therefore, from this point A to this point B, AB is basically giving you the line of sight. This girl is observing this object which is the balloon, and so AB becomes the line of sight, and the angle between the line of sight and this horizontal line AC is your angle of elevation, which is 60 degrees. After this, let's see what happens. After some time, now I don't know how much time, after some time the angle of elevation reduces to 30 degrees. So, after some time what happens, this girl's angle of elevation reduces to 30 degrees because the balloon is keeping on moving. So, the balloon moves, come here, and here when the girl is watching the balloon, when the observer is watching the object, the angle of elevation comes and reduces to 30 degrees. Still, do not forget, because the balloon is moving in a straight horizontal line, the height remains the same, which is 88.2 meters. Height remains the same. Okay, and so after some time, I don't know how much time, the angle of elevation reduces to 30 degrees. Okay, because the balloon from this point travels and comes to this point. And that is where the girl is observing the balloon. So, after some time, the girl's observation of the balloon comes over here, and in that case, the angle decreases to 30. The question is, find the distance travelled by the balloon during that interval. So, how much has the balloon travelled? This much is the distance which the balloon has travelled. Now, this distance is same as this distance is same as this distance, right? What I am saying is, this is also the same distance which this is, and it is the same distance which this is. That means I have to find how much the balloon has travelled from here to here. That means this is the distance I wish to find, this is the distance I wish to find, or this is the distance I wish to find. Okay? So, what am I going to do is, I am going to take this distance to be y and this distance to be x. And so, this comes out to be y minus x. That's what I have to find. I have to find y minus x. So this is y, this is x. By this I mean this entirely is y and this entirely is x, by which I mean this much is y minus x. Now the moment I am able to find y and I am able to find x, I will be able to find y minus x. So let's start understanding what will be the values of y and x and then compute the value of y minus x. So let's get started. This is A, this point is B, this point is C. Suppose I take this point to be D and this point to be E. Let this be F, G and H. Now, understand in this case you're getting two right-angled triangles with 60 and 30 degrees sitting at these positions. So one by one, let's consider both these right triangles so that we can work with 60 degrees and 30 degrees both. So first, let's pick up DAE. In triangle DAE, if I work with tan 30, what is tan of an angle? Tan ratio of an angle is proper brushing. So perpendicular upon base. The perpendicular is this. What is this? DE upon the base of the triangle DAE. The base is AE. Now understand. From A to H, the length is 1.2. That means from this point E to point F, this is 1.2. So from D to F, the length is 88.2 and from E to F, it's 1.2. So from D to E, what is the length? Isn't it 88.2 minus 1.2? Now this much is 88.2, this much is 1.2, so this much is 88.2 minus 1.2, and 88.2 minus 1.2 is what is your DE upon AE. So AE has length equal to y. And what is tan 30? Tan 30 is 1 by root 3. That means from here you can compute y. Your y comes out to be equal to 87 root 3 meters. Y you have come to know. Next is to find x. So let's take the use of the next right angle triangle, which is ABC. In triangle ABC, what are we going to do is, again we are going to work with tan ratio. Tan 60. What is tan 60 now? Tan 60 is proper brushing. So perpendicular, which is BC, upon the base, which is AC. Now the length of BC is same as the length of DE, and the length of DE was 88.2 minus 1.2, which is 87. So this also has length as 87. And AC on the other hand has length equal to x. And you know tan 60 is nothing but root 3. So you know what x is. X has come out to be 87 by root 3 meters. Now you know what your y is, you know what your x is. Your aim was to find y minus x because this is the distance travelled by the balloon. Fine. So y minus x is what? Your y is 87 root 3 minus 87 by root 3, which gives you what? This becomes 87 root 3 multiplied by root 3. So 87 into root 3, which is 3, minus 87 divided by root 3. What is this? 261 minus 87 divided by root 3, which gives you 174 by root 3. Or you can further simplify it as 174 into root 3 divided by root 3 into root 3. You can just multiply and divide by root 3. You are going to get 174 root 3 divided by 3. And this will be 358 root 3. That happens to be the value of y minus x. That means the balloon has travelled a distance of 58 root 3 meters in that time interval. And that is what is your answer, which is again sitting at option number B. This is how the chapter which concerns with this question is the applications of trigonometry. This is very easy question. The only task was to interpret the question and then work with the ratios corresponding to the two angles given in the picture. And then very easily by simple computations find out the value which gives you the distance or the length of that distance which is travelled by this balloon from here to here. Okay? That is how we deal with questions like these. Now, once this task is clear to you, let's see what happens to be my next question. The next question in this league, in section A, is talking about, let's see what? Tickets are numbered from 1 to 50. They are mixed up together and then a ticket is drawn at random. Okay. So there are 50 tickets. Each one of them has a different number from 1 to 50. So some has number 1, then number 2, then number 3 and so on till 50. So there are 50 tickets, each one having a number from 1 to 50. And all of them are kept together. Okay. And then one card is drawn at random from there. From the lot of 50 cards which have numbers from 1 to 50, I am putting in my hand and drawing one card at random. What is the probability that the card that you have drawn or the ticket that you have drawn has a number which is a multiple of 3 or 7? Okay, so there are tickets which have numbers from 1 to 50. So obviously there are tickets which have numbers which are multiples of 3 and 7 also coming from 1 to 50. So from the range of 1 to 50, what are the several multiples of 3 and 7? Let's collect them. Multiples of 3 and 7 from 1 to 50 are what? Okay, so starting from 1, 2, 3 is the first multiple of 3, 4, 5, 6, 7 is a multiple of 7, 8, 9, 10, 11, 12, 13, 14, then 15, 16, 17, then 18, 19, 20, then 21, then 24, 25, 26, then 27, 28, 7 4s are 28, 29, no, 30, 31, no, 32, no, 33, 34, no, 35, 36, 37, no, 38, no, 39, 40, no, 41, no, 42, 43, no, 44, no, 45, yes, because 45 is a multiple of 3 coming in the range from 1 to 50. 46, no, 47, no, 48, 49. That's it. 50 is neither a multiple of 3 nor a multiple of 7 and we cannot move beyond 50 because the tickets are numbered from 1 to 50 only. And so these are the numbers which are multiples of 3 or 7. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So they are 21 in number. Now if you have 50 cards with you, 50 tickets with you, having a number from 1 to 50, I am interested in drawing a ticket which has a number which is a multiple of 3 or 7. That means I am interested in drawing a ticket which has either of these numbers. It should have a number which should be either of these numbers, okay, one of these numbers only. I am interested in drawing a ticket which has exactly one of these numbers. That means the favorable outcomes for me are these 21 tickets, or 21 tickets are my favorable tickets which have these 21 numbers upon them. Out of a total of 50 tickets, which is my total number of outcomes which can come when I draw one ticket, out of them the favorable tickets are the tickets, 21 tickets which have these 21 numbers. And that is why if A is the event of drawing a ticket having a number that is multiple of 3 or 7. So if A is the event of drawing a ticket having a number that is a multiple of 3 or 7, then the question is this only: give me the probability that the ticket which has been drawn, the single ticket which is drawn, has a number which is a multiple of either 3 or 7. That means give me the probability that the ticket drawn has a number 1 among these 21 numbers. Out of the 50 numbers, I am interested in just 21 numbers, and that is why probability of event A, probability of drawing a ticket having a number which is a multiple of 3 or 7, is number of favorable outcomes upon number of total outcomes. So favorable outcomes are just those 21 tickets having these 21 numbers. So the number of favorable outcomes is 21 out of the total number of outcomes. So the total outcomes are 50. Overall there are 50 tickets. And so 21 upon 50 is the required probability of drawing a ticket which has a number which is multiple of 3 or 7. So this happens to be the correct option. Very easy, very simple question. You should just know the formula of probability and then you will be able to sail through this question. Okay? Note this down. This was very easy. The only task was to collect the correct number of multiples of 3 or 7 ranging from 1 to 50. That is the only task required, and after which we used the formula of probability and then we got the correct answer. So note this down and then we are going to move further. Okay students, so take a look at the next question and see if you are able to do it or not. Again, a very easy question. Just take a look at it, read it, and then we are going to deal with it. What is the question trying to say? It is saying there is a wire. Okay, so there is a wire. Suppose this is your wire, okay? Now this piece of wire, the question is saying this wire is looped so as to form a circle. So from this wire, there was a wire, I just looped it up and formed a circle. Understood? And that circle which is formed is a special circle because the diameter of that circle is 84 centimeters. This is the center of the circle and the diameter of the circle is of length 84 centimeters. The moment you know the diameter, you know that the radius is half of the diameter, which is 42 centimeters. So there was a wire, I don't know which length wire. That wire is basically looped in a circle and that circle is such that its diameter is coming out to be 84 centimeters. So the wire has length such that when it is looped in a circle, that circle has diameter 84 centimeters. Further, what happens? This circle is rebent in a square. So this circle is rebent to form a square. So after this, I move the circle which I had is rebent into a square. Exact same circle is rebent into a square. It's not stretched, it's not contracted. The exact same circle which was there was rebent into a square. This is the square. Now this square will have a certain side. All the four sides are of same length in a square. Right? So understand what the question gave you. The question gave you a certain length wire, and then it said that wire has a length such that when it is looped in the form of a circle, that circle is coming out to be of diameter 84 centimeters. Now once this circle is made, it is rebent, the corners are basically made and it is rebent into a square, and that is what is bringing this square into picture. So from step 1, I am moving to step 2. And then from here I move to step 3. The question is, what is the length of the side of the square? That is what we have to find. This. Now understand carefully. This piece of wire, when it is made into a circle, that wire is now sitting as the boundary of the circle. And when this circle is rebent into a square, this same boundary is now the boundary of the square. So this length wire is first the boundary of the circle, after which it is becoming the boundary of the square. Right? That means both the circle and this square have the exact same length boundaries. Now what is the length of the boundary of this circle? The length of the boundary of this circle is nothing but the circumference of the circle. Isn't it? What is the perimeter of this circle? The length of the boundary of this circle is the perimeter, or the circumference, I can say. And the length of the boundary of this circle, which is nothing but the length of this wire, because the same wire is used to make this square also, because the same circle was rebent into a square. That means the exact same length wire was used now to make a square, and that length wire is now the length of the boundary of the square, which is nothing but the perimeter of the square. Correct? So the question is just trying to say that a wire was made into a circle. Okay, so whatever is the length of that wire, that is the length of the boundary of the circle, and because the same circle was rebent into the square, that same length boundary is now the length of the boundary, or the measurement of the boundary of the square. And therefore, the measurement of the boundary of the circle and of the square are exactly the same, which means the perimeter of the circle and perimeter of the square are exactly the same. And now we use the formula of perimeter of a circle. What is the perimeter of a circle? It is 2 pi r, where this r is the radius of the circle. And what is the perimeter of a square? It is 4 into side. This is the side of the square. Understood? Now what is the radius of the circle? The diameter is given to me, so the radius is given to me. It is 42 centimeters. Pi is what? Pi is 22 by 7, and you have a 2. So 2 pi r, this is equal to 4 into side. Now what happens? This gets cancelled. You get 44 upon 4 into 6 is your side. And so this becomes 11 into 6, which is 66 centimeters. And so the side of the square will be 66 centimeters, and so such that the perimeter of this square, which is the measurement of the boundary of this square, which is 4 into 66, that will be equal to the measurement of the boundary of this circle, which is 2 into pi into 42. Okay? With side length equals 66, its perimeter and its perimeter will be the same. Okay? Because the same wire is made into a circle and is made into a square. So the only concept which is required is that you have to understand that the length of the boundary of the circle and the length of the boundary of the square are exactly the same. I am not stretching and I am not contracting the wire. It's a wire, it cannot be extended or contracted. And so the wire's length remains the same because this wire is coming in the form of a circle now. So it has become a perimeter of the circle and then it is being made into a square. So then the length of the wire has come out in the form of perimeter of a square. The length of the wire will not change, so both the perimeters will remain the same, and that is what has given me the side of the square. Okay? Fairly very easy question. Okay? The only thing you need to understand is how to find out the length of that wire, or basically using that concept, how to find out the side of the square for which the boundary length of the circle and the square are the same. And so in this case, the answer will be again a 66 centimeters. Understood? Now that we have dealt with question number 6, let's see what question 7 has for us. Okay, question number 7 is again giving you a quadratic equation, isn't it? X square plus kx plus 64. This is a form of quadratic equation only. Now this has equal roots. The question is saying for this equation to have equal roots, what should be the value of k? Now for that, just recall a certain concept. If you have the quadratic equation ax square plus bx plus c equals 0, then roots of this equation are given by roots of this equation means the values of the unknowns x, which when plugged in over here satisfy this equation, equate it, or the answer comes out to be 0. Those values of x's which when you plug in over here you get a 0 are the solutions of this quadratic equation or the roots of this quadratic equation. And the way to find the roots of this quadratic equation is through the Sridharacharya formula, which is x is equals to minus b plus minus under root b square minus 4ac upon 2a, where this under root b square minus 4ac is called the discriminant determined by d. Okay? And then three cases arise. If this d is strictly greater than 0, you know that you get two unequal real roots. So two unequal real roots of a quadratic equation can be obtained only when the discriminant is strictly positive. If this discriminant is 0, then you are going to obtain, I should not write 2 because if the two roots are equal, they become just 1. So you get equal real roots. That means the two roots which you get of this quadratic equation are equal to each other only and only when the discriminant of this quadratic equation is 0. Understand the two cases. Now this quadratic equation can have only two roots. If the discriminant is positive and only when the discriminant is positive, then you get two unequal real roots. Okay? But the moment discriminant is 0, you get equal real roots. They are real, but they are equal to each other. They are no more unequal and distinct. And the moment third case arises, which is D is less than 0, it comes out to be negative. This discriminant quantity comes out to be negative. You get non-real roots. Right now the question is demanding what? It is saying, give me the value of k for which this quadratic equation has equal roots. This quadratic equation can have equal roots only and only when the discriminant is 0. If the discriminant is not 0, this equation cannot have equal roots. So for it to have equal roots, the discriminant of this equation should be 0, which is x squared plus kx plus 64. X squared plus kx plus 64 equals 0. Now compare it with this. What is A? A is 1. What is B? Coefficient of x. So here your B is k. And what is C? C is the last constant term, which is 64. Okay? Now once you know what are A, B and C, if you want equal roots of this quadratic equation, you are interested in determinant to be equal to 0, which means you want under root b square minus 4ac to be equal to 0. In fact, the discriminant is not with the under root sign, it is only b square minus 4ac. B square minus 4ac is the term which is known as the discriminant. So when the discriminant is positive, means when this is positive, you get two unequal real roots. When discriminant is 0, means when this is 0, you get equal real roots. And when discriminant is negative, means when this is negative, you get non-real two roots. So over here, if you want equal roots, discriminant should be 0. That is b square. B square means k square minus 4 into A into C, this should be 0, which means k square minus, what is 4 into 64? 256. So k should be, or k square should be 256. Now just from this fact I have observed that k square should be 256, that means k should be plus minus 16, because 16 square is 256. So when you take under root both sides, you get k equals plus minus 16. That means by using the concept of equal roots, which occur only when the discriminant of a quadratic equation is 0, we applied that concept to this quadratic equation and we found our values of k, and these are those values of k which when plugged in this equation are going to make this equation such that its discriminant will be 0, and so they are going to have equal roots. I am not interested in what those equal roots are. What I am interested in is for which value of k will this equation give me equal roots. And that value of k is 16 and minus 16. Again and again, questions from quadratic equations are asked in the papers. You should be aware about the nature of the roots of a quadratic equation. When can a quadratic equation possess two unequal real roots? When can it possess equal real roots? And when can it possess unequal and non-real roots? Okay? Now let's see the last question of section A. Okay, so it is saying if AB is 4 meters and AC is 8 meters. Now where is A, where is B, where is C, I don't know. Let's further read the question to find that out. Then the angle of observation of the point A as observed from the point C. So from the point C I am observing point A. So point C is sitting as the point of observation, and somewhere above point A is sitting as the object. So from point C I am observing point A, so this CA becomes my line of sight. And the length of this line of sight is given to be 8 meters. Okay? Then if this is the point of observation and this is the object, this becomes the line of sight. If I draw a horizontal line passing through point C, the angle between the line of sight and the horizontal line passing through point C is my angle of elevation. The angle of elevation or the angle of observation, both are exactly the same things. So this is my angle of elevation or angle of observation of point A from point C. Now this picture is clear. Now from A to B, some point B is here on this line. So from A to point B, this distance is 4 meters. That's what is given to you. Okay? The question is, find the value of this angle. So just understand, there is a man whose eyes basically are here, that is what I am trying to say. Somebody from here is observing the object kept at point A, and so AC is the line of sight with 8 meters as the length. From A to B, where B is the point on the horizontal line passing through C, is 4 meters. And then the angle between the line of sight and this horizontal line is the angle of observation, which is the angle made between these line of sight and the horizontal line, the angle which is the angle of observation of point A from point C. And this angle is the angle whose magnitude we need to find in this question given these certain things. So over here I have this right angled triangle. So the only trigger point is that I wish to use trigonometric ratios, either sine or cos or tan or cosec or sec or cot. Let's start with sine and see if sine gives you the correct answer. Why to move for cos and tan? So let's see. If I am interested in sine theta is going to make use of perpendicular and hypotenuse. And that are the two things, or that are the two sides of whose lengths I am given. I am given the length of perpendicular side of this triangle ABC, and I am given the length of the hypotenuse side of this triangle ABC. And sine requires the lengths of these two sides only, perpendicular upon hypotenuse. So the perpendicular upon hypotenuse, where the perpendicular is AB and the hypotenuse is AC. So AB is 4 and this is 8. So what is it that you get? 1/2. So give me an acute angle. Now this is a right angle triangle. That means this and this, they are acute angles from 0 to 90 degrees. Because inside a right angle triangle, you cannot have two 90-degree angles. Okay? So in a right angle triangle, there is only one angle which is of 90 degrees. And the rest two angles have to be acute angles. That means this theta is an angle from 0 to 90 degrees. Give me that angle from 0 to 90 degrees whose sine ratio is 1/2. We know the only angle from 0 to 90 degrees whose sine ratio is 1/2 is 30 degrees. And therefore, the angle of observation or the angle of elevation of point A or the object A from point C is 30 degrees. And that is what is my correct answer. Pretty easy question. The only task in any question we have seen till now is to interpret that question in a mathematical way. The moment you are able to interpret the situational question in a mathematical way, you are through, halfway through. And then you have to understand and recall the concepts which can be applied now. Recalling the concepts, applying them is going to finish your entire task of solving the questions. So here I complete with section A. You are supposed to practice them again, revisit them, understand the techniques, the ideas which were used to solve them, tackle them, and then be prepared to combat in the next session, the section B.